Scientific notation is used by scientists and mathematicians as a way of abbreviating very large or very small numbers. Some historians believe that it originated in the time of Archimedes, about 287 to 212 BCE, when he was asked to estimate the number of grains of sand in the universe, a number which he estimated as the equivalent of 1 times 10 to the 63rd, which is a 1 with 63 zeros after it. So let's proceed by defining exactly what scientific notation is, and then writing some numbers in scientific notation. So we define scientific notation as a number called a coefficient, and we'll call that number A, times 10, and it's always 10, to some power called an exponent. So if we write the number 3.5 times 10 to the third, the coefficient is 3.5, 3.5. The exponent is 3. Now what this means is 3.5, 10 to the third, 10 times 10 times 10 is 1,000. So this is 10 to the third, so that's 3.5 times 1,000, which equals 3,500. Let's take a much bigger number. 4.7 times 10 to the 10th. So this number is 4.7 times 10 to the 10th. Now I can write out 10 to the 10th, but the way to write this number without writing out 10 to the 10th first is to take 4.7 and move the decimal point over 10 places to the right, adding a 0 when necessary. So we're going to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we need to add a 0 in each one of these empty places. So 4.7 times 10 to the 10th, and if we were to put commas in here, that would be 47 billion. Now what happens with very small numbers? Well, with small numbers, we can use negative exponents. So let's take a look at one of those. Let's take 8.72 times 10 to the negative 2. So in order to convert that number into standard notation, we write 872. And instead of moving the decimal place to the right, we move it to the left 2 places. So it starts here, we move 1 and 2, put a 0 in the empty space, and then usually when we write decimal numbers that begin with a decimal point, we put a 0 in front, just to call that out. So 8.72 times 10 to the negative 2 is 0.0872. Let's do one more. 9.76 times 10 to the negative 7. Now, we should start over a little bit. So 976, and we'll move the decimal place point to the left 7 spaces. 1, 2, 3, 4, 5, 6, 7. Decimal point goes there, and we need to fill in the zeros. 1, 2, 3, 4, 5, 6. So 9.76 times 10 to the negative 7 is equal to this decimal number that you see here. Now let's take a look at how to take a number in standard form and write it in scientific notation. So we'll start with the number 470,000. Now we know that the coefficient is going to be 4.7, and we don't need all of the extra zeros because we'll take care of that with the exponential term. So this is going to be 4.7 times 10 to some power. Now, in order to rewrite 470,000 as 4.7, we needed to move the decimal place over 1, 2, 3, 4, 5, so that says that the exponent needs to be 5, so that will move the decimal point in 4.7 back the 5 places. Let's take another number, 872. So we know that the coefficient is going to be 8.72. And since we moved the decimal place 2 spaces to the left to write it in scientific notation, we need to move it back to convert. So that's times 10 to the second power. Now let's take a look at some smaller numbers. 0.0013. Well, the coefficient is going to be 1.3 times 10 to some power. And since we moved the decimal point to the right to get 1.3, we need to move it back to the left 3 places in order to get back to the standard notation. One more, 0.000540. We know that the coefficient is going to be 5.4, and we can see that we needed to move the decimal place 1, 2, 3, 4 places to the right in order to make 5.4. So we need to move it back 4 places to the left to write it in scientific notation. So these exponents are all about which direction to move the decimal point. And this is how you convert numbers from standard form to scientific notation.